Swayam Prabha. Digital India. Educated India.
Hello and welcome back everyone. We are learning the basics of building construction and we are currently studying the module on roofs. So in the previous lecture we had discussed about different types of pitched roofs, the terms associated with it, and we had just ended our discussion about steel roof trusses. So in today's lecture we are going to continue the discussion by studying the different types of steel roof truss and then move on to understanding the options for roof coverings. Just as a quick recap so that we know where we stand, we were studying about the different types of pitch roofs. So we had learnt about single roof, double or purlin roof and triple or trussed roof. So different types of single roofs we have already learnt about. We have seen how in double roof we have, in addition to the common rafters, we also have an additional member for intermediate support, that is the purlin. Then we moved on to trussed roof. Here we have three members. We have the common rafters, the purlins for intermediate support and the truss. So this allows us to deal with spans without any internal wall for the supporting of the purlin. The purlin comes and rests on the truss itself. Now within the trussed type of roof, we had studied king post, queen post and a combination of that. We then moved on to different types of materials that we can use for trusses. So we can have timber trusses, we can have a combination of steel and timber, and we can also have steel sloping roof trusses. So we just had started the discussion on steel sloping roof trusses in the previous lecture. Now we are going to continue that discussion and go into the details of it. Now steel roof trusses are used when the span is more than 10 meters and it becomes uneconomical to stick to timber, unless of course we are dealing with hilly area constructions where it may be a bit more economical to stick to timber. Otherwise, under most circumstances, for all types of buildings, we can always switch over to steel roof trusses beyond a certain span. Now this becomes more economical. Now the steel trusses can range from small to large as well. So it's not that we do not opt for steel roof trusses if we are dealing with a smaller span. We can still choose to select them if timber is not our preference in material. Now steel becomes more economical as well as preferable to timber for several reasons, not just from the span point of view, but it is also easier to construct or fabricate based on the angles and channels which are available. We can use those members very easily. They are fireproof as opposed to a timber trussed roof. Obviously timber will be far more inflammable as compared to steel roof trusses. It is far more rigid and more permanent in nature. So from the durability point of view, it will be expected to last longer. Now the steel trusses are fabricated from roll steel structural members. We can use channels, angles, T-sections and plates to create our steel roof trusses. And most of the roof trusses are fabricated from angle sections. That is the most popular choice because they can effectively resist both tension as well as compression, and the joints are much more easier to construct. Now steel trusses have practically superseded timber trusses in India, where timber can be considered quite costly in most locations except for hilly regions, as already discussed. Now there may be several shapes that we can opt for when we are dealing with steel roof trusses, depending upon the type of span that we are dealing with and the overall shape or architectural style we are going for. But overall we can say that steel trusses can be grouped into the following categories. We can have number one, open trusses. We can have a north light trusses, bowstring trusses and arched rib trusses or solid arched trusses. Now different types of steel roofs are possible. If we look at these shapes, the first one is the king post truss. We already know that a king post truss is the one in which there is a vertical member, which is called the king post. So we can definitely make king post trusses with the help of steel. We can have a scissor truss. So here we have two members which are meeting in the form of a scissor. We can have a raised chord truss similar to the previous example, but here what we've done is we have created a chord which is slightly raised. This helps the thrust action from acting on the members at the wall plate level. We can also have a hoe truss. So here we will have, in addition to the central king post, we have additional vertical posts as visible here, and of course associated with that we can introduce necessary number of struts. We can have a simple fink truss, as it is evident here. Depending upon the types of members, the position of the struts, we can give it different types of names. Now the simple fink truss here, the struts are not exactly at 90 degrees, as you can see it's slightly at a different angle. We can have the fan fink truss, similar to the simple fink truss, but here the number of members, number of struts that we are having, the inclined members are more. The knot-like trusses are the ones which are actually allowing us the opportunity to create the knot light in one side. So it is raised at a certain angle and one side is open. If we have it in the northern direction, it can allow us to introduce light into our internal spaces from that direction while avoiding the glare of the southern sun. Now the knot light trusses can either have a completely straight edge or it can also have an inclined edge. We can have a sawtooth or a weaving shed truss where we have back-to-back knot-light trusses. We can also have a modified knot-light truss like so. And we can also have a bowstring truss, in which case the shape would be curved. This is an example of the compound fink truss, similar to the simple or the fan fink truss, but here the number of members are much more. Obviously the span we will be dealing with will be more in this case. We can also have a compound hoe truss, similar to the hoe truss, but in this case we are having a raised chord. So we will have this chord which is raising the overall structure. We can have a compound hoe truss. This will be similar to the hoe truss, just made for a bigger span with larger number of members. We can also have a compound fan fink truss, as we were seeing in the previous slide where we were talking about the fan fink truss. Here it is similar to that, just the number of members are increasing, so the span is increasing. We can also have a cambered fink or a French truss like so. Now going back again to the beginning, we will see that the span varies in all these cases. For example, the king post truss, if we go for this option, we can stick to 4 to 6 meters. Scissor truss also 4 to 6 meters. But the moment we go for raised chord trusses, we can actually increase it up to 9 meters, 6 to 9 meters. The hoe truss can go for 9 to 12 meters. The simple fan fink trusses, we can restrict ourselves to about 9 to 12 meters. Knot light also 9 to 12 meters. The bowstring truss, on the other hand, can go up to 20 to 30 meters in span. The compound fink trusses and compound hoe trusses will have much larger span. They can accommodate 12 to 15 meters in span. So as we go for more number of members being introduced to take the different compression and tension aspects of this truss, we can actually keep increasing our span. So depending upon the type of internal space we are dealing with, the amount of columnless internal space we require, we can increase the span of our truss by introducing additional members. So based on our requirement, we can go for these options. Now as you will notice, most of it, except for the king post truss or the initial types of trusses that we were looking at, most of it are above 10 meters. So in a situation where it becomes uneconomical to stick to timber trusses, we can switch over to steel trusses. And as you can see, the members are designed in such a way that it is able to take tension and compression better. So this type of steel roof trusses will find much greater applicability depending upon the type of architectural design we are dealing with. Another type of steel truss application is the industrial building vents. Now they are usually made up of roof truss which is supported on steel stanchions, and they are used in big factories or mills. So in case of factories, you must have seen very large columnless spaces within which we can operate very easily. So to be able to create that, steel stanchions are used as the structural vertical members above which these industrial building bends are supported. Now these bends are transversely braced, and the roof trusses are supported on columns which are providing structural support to this overall building. Now asbestos corrugated or Trafford cement sheets, galvanized corrugated sheets can be used as roof covering materials. So different types of roof covering options are available. Commonly in factories you must have seen that such trusses are surmounted on the top with the help of corrugated sheets. That is one of the most commonly used materials for the roof covering. Overall, this also prevents a lot of fire hazards in factories. It's a very big risk in factories or industrial areas. If we use inflammable materials like timber to create trusses, definitely it's going to be a big issue. So not only for the structural reason, not only for the fact that we cannot have very large columnless spaces in case of timber, the cost of making the members, the cross section of the rafters and the other members used in the timber trusses would exceed drastically, making the overall roof structure heavy as well as increasing its price. So definitely for that purpose, to be able to span a very large gap without the use of any intermediate support, we can definitely go for steel trusses. But in addition to that, it also reduces the fire hazard significantly. Now the factors that should be considered before designing industrial building bends is that, first of all, we have to select the type of roof covering. So based on the type of roof covering, it will also determine the type of distance that we select for the different members, and the covering that we provide intermediate to the rafter members and the roof covering on top. The insulation properties which are required, the acoustical properties, most of the industrial areas were also going to be source of a significant amount of noise. The appearance that we choose to have from the inner side, from the internal space point of view, the overall weight and the maintenance requirements. So the options that we can go for is, we can have a frame with fin truss as shown here. We can have a skylight on top of this fin truss. We can go for a frame with Pratt truss as depicted here, or we can also have an arch truss. As you can see, there is a certain curve to the internal space. So depending upon the appearance that we want within our internal space and also the span that we are dealing with. For instance, the previous examples on the top are 12 to 15 meter span, whereas we can increase that to about 15 to 20 in the lower two examples. So the span, the type of roofing material, the internal appearance, the overall weight, what are the maintenance requirements, all these factors are going to help us determine the type of truss that we are selecting for our industrial building bend. What are the different advantages that we can have in the steel roof truss over and above the timber trusses? So first of all, the sections comprising of a steel truss are readily available in the desired dimensions, ensuring minimum wastage of material. So we are not going to have to create individual members. We have fabricated options available to us to choose from. Now the steel trusses are light in weight and they can be fabricated in any shape depending upon the structural and the architectural requirements, whereas in case of the timber truss, our options of different shapes are limited. We can only, if we for instance want to go for a curved truss with the help of timber members, we are going to have to cut the timber into very thin sections, very closely spaced. So the restrictions will be more in case of dealing with a timber truss. Steel trusses are of course stronger, they are more rigid in comparison to the timber trusses, and the steel members are strong in tension as well as compression, whereas in case of timber it would be good at taking compression, but for tension steel would be preferable. Now steel trusses can be used over any span, while timber trusses are usually suitable if we restrict our span to about 10 meters. There are some examples of timber trusses where we can go beyond that, but it becomes increasingly costly. Steel trusses are most definitely fireproof and termite proof, which is a huge advantage. It increases the longevity and reduces the possibilities of accidents. Now, steel trusses are most resistant to other weather elements as well. As a result, their durability are expected to be much higher as compared to timber trusses. Now, the fabrication of the steel truss is easier and quicker because the sections can be shaped and made in the workshop, and they can easily be transported and just simply assembled in the construction site. Now, let's move on to the details of the steel roof truss. So, the steel roof trusses are usually fabricated from angle sections and plates, although we can also use channels and T-sections. Now, the members of the roof truss carry only the direct stresses, that is either compression or tension, and no bending stress should be induced. Now, the principal rafters as well as the main tie are generally made up of two angle sections which are placed side by side, while the struts and the ties are generally made of a single angle section. The members are jointed using a gusset plate, now either with the help of rivets or by welding it together. Now, the minimum pitch should not be less than 3 times the rivet diameter, while the maximum pitch is limited to 15 centimeters for compression members and 20 centimeters for tension members. Now, for small spans, 15 mm diameter rivets are used and 20 mm rivets are used for larger spans. At least 2 rivets should be used at each joint. So, as you can see here, there are gusset plates used as and where we need to connect different members together. They are either welded into position or we can use rivets. The gusset plate should not be less than 6 mm in thickness. It is of course designed in such that it is able to take the forces from the various members that it is helping connect. Now, the short angles are fitted on both the sides of the gusset plate at the foot of the truss, which are connected to the bearing plate. Rag bolts are used to join the bearing plate with the concrete bed. Now, at the apex, suitable ridge section is fitted at the top. So, that was all we needed to study about the steel roof trusses. So, with that we are able to cover all the types of pitch roofs. Now, let's start looking at the different types of roof coverings. So, we have a lot of options available to us depending upon the weather conditions, the architectural style we are going for, the materials which are locally prevalent, the cost that we want to bear, the type of truss we have selected. Several factors will help us determine which type of roof covering is most suitable for us. We are going to be studying the roof coverings for pitch roofs here. Now, for flat roof structures, the type of terracing material that is generally used on top of the roof surface to ensure waterproofing is going to be part of the damp proofing module, which is slightly down the line. So, that is not going to be covered in this particular module. Here we are going to stick to the roof coverings associated with pitch roofs only. Now, the roof covering is an important component of pitch roof that is placed over the roof framework to protect it from rain, snow, sun, wind and other atmospheric factors. Now, the selection of the roof cover depends upon number 1, the type of building. Definitely we are not going to use thatch as a roof covering in a public structure. So, depending upon the type of building we are dealing with, the usage, its scale, we can go for a particular type of roof covering. The type of roof framework that we have selected will of course determine the type of roof covering we want to go for. The initial cost or investment, because there are certain roof coverings which will become increasingly costlier as opposed to others. So, definitely budget is an important factor. The maintenance requirements are also a very essential factor, because it may so happen that we have selected a particular type of roof covering where the initial cost may be low, but the recurring cost or the maintenance cost keeps adding up. So, we may look at it from a totality point of view, where we see what is the overall cost associated with not only creating this type of roof covering, but also maintaining it over the lifespan of the house. So that has to be another very important factor to be considered when we are dealing with pitched roofs, because unlike flat roof structures with terracing, the amount of maintenance that generally goes into pitched roofs is far greater. The recurring cost is more. The fabrication facilities which are available to us, the overall appearance that we are trying to go for definitely is going to determine our roof covering, because the aesthetics are also going to play an important role. The durability, and with the durability comes the associated maintenance requirements as well. So for materials which are less durable, the amount of maintenance will have to be more and more frequent over the lifespan of the building. So durability is an essential factor. Also, depending upon the weather conditions, we have to select materials which are of higher durability if we are dealing with far greater amount of rainfall or more type of amount of snowfall that the structure receives. So where we are building our structure, the location is also going to be very, very important in determining what type of material we need to select, whether or not we want a more durable type of roof covering. The availability of the material also is important, because if we are going for pitched roofs, it may so happen that we would like to select a roof covering which is locally available. So depending upon what is locally available to us, we can reduce the transportation costs, and also it overall suits the building given the architectural setup in which our building is being created. Climate and special features of the locality. There may also be a situation where we are dealing with form based coding, that is a specific color is expected in our structures. We have to conform to certain norms of a certain locality. So that may also aid us in selecting the appearance of the overall building. Now roof covering are going to form a very important aspect of the facade and the overall look of the building. So those aspects will have to be considered while making our final selection. Now the following are the popular type of roof covering materials which are available in today's market. New materials are coming in every single day, but the popular ones which have been traditionally in use and have dominated the market have been listed here. The first is called the thatch covering, very, very popular in rural areas mostly. Not that we cannot see it in certain parts of suburban areas as well, is thatch covering. The second is wooden shingles. Third, very, very popular type of roof covering is tile. Also because different localities, especially in India, different parts of the nation have different shapes of tiles which are locally available. So you would see very distinctive tile types selected in different parts of the nation. So tile is also a very, very popular roof covering. Then of course comes the sheets. The asbestos cement sheets, the galvanized iron corrugated sheets are very popular choices as well. The durability of this also will vary from the tile. The Eternit slates and lightweight roofing materials are another category. So we're going to now dive in depth into each of these subtypes, trying to understand the advantages and disadvantages of each and where they find applicability, keeping in mind the durability, their inherent properties, the maintenance cost, the initial cost, and of course the aesthetics we are going for in our building. So the first one we are going to take a look at is the thatch roof. Now this is the cheapest type of roof covering that is available to us. It is more commonly used in villages. Now it is very lightweight, but unfortunately it's very highly combustible. Now this is not durable against very high winds or storms, and it can also absorb a lot of moisture, and hence it is liable to decay. So that means the durability, its resistance to weather elements is limited, but of course it is very economical, very lightweight. As a result, it doesn't put a lot of pressure on the building itself, the lower part of the walls. So as a result, if we want a lightweight structure, maybe on top of adobe construction, or we do not have very good structural members taking the load of the walls, we may want to go for this type of roof. Now the thatch roof covering consists of bundles or reeds of straw. Now the framework to support the thatch consists of round bamboo rafters which are spaced at 20 to 30 centimeters center to center, and they are tied with split bamboo laid at right angles to the rafters, like so. So this will help us create the framework above which we can use the split bamboo to hold the different bundles of straw in position. Nonetheless, though we are providing some amount of weight on top to keep it in its position, very high gusty winds will cause this particular roof to be damaged. Now the reed or straw must be well soaked in water or any other form of fire resisting solution to facilitate packing, and the bundles are then laid at sharp ends pointing towards the eaves. So the sharp ends are actually going to be pointed downwards along the eaves. Now why we do the soaking beforehand? To ensure that some amount of fire resisting properties has been given to the straws. In addition to that, it also makes them more manageable and easier for us to fix them in position and keep the overall thatch in order. Now the thatch is tightly secured to the framework with the help of ropes or twines which are dipped in tar. Now the minimum slope of 45 degree is kept to help drain the roof effectively. So that is why we are opting for a greater angle. So not sticking to 30 degrees, we are going up to 45 degrees minimum slope for this type of roof, because if the rainwater stagnates at any point, it will actually aid in decaying of the thatch. Now because thatch is something that's not going to be very durable, we do not want the water to stand at any point, and it needs to be immediately drained off, hence the higher angle. Now the thickness of thatch covering should be at least 15 centimeter. Normal thickness varies between 20 to 30 centimeters depending upon the quality and the pitch of the roof. So depending upon what angle we have selected, we can go for a varying thickness, but preferably 20 to 30 centimeter of thickness should be given when we are fixing our thatch together. The next type of roof covering that we can opt for is called the wood shingles. Now shingles are actually thin slabs of wood that are used to cover roofs. Now the shingles are common in hilly areas where timber is very easily available at a low cost, so we can actually go for abundant use of timber. So in addition to making the framework above which the roof is being supported, which is made up of timber, we can actually go for timber roof covering. Now shingle roofing is very lightweight, but this is not fire or termite resistant. Now wooden shingles are obtained from well seasoned wood because we want to of course increase the durability of our roof covering, and sawing or splitting is used to make them into very thin sections which can be easily placed, as you can see in the figure. Now sawn shingles are commonly used. Now they are made in lengths of about 30 to 40 centimeter. That means if we see each particular piece, this would be about 30 to 40 centimeter in length, 30 to 40, and the width may vary between 6 to 25 centimeter. Now they are approximately 10 mm in thickness at the tail end and taper to about 3 mm or less at the head. So that means if we see it from the side, the cross section is different at the two ends. One side it is slightly thicker. Now they are laid in a similar manner to tiles or slates. So we are arranging them in certain courses at a certain order, one after the other. The next type is the tile roofing. Tile roofing is one of the oldest and most commonly used roof covering. It finds maximum applicability in pitched roof residential houses. Now these tiles are usually manufactured from locally available earth, and the tiles are named according to their shape and pattern, and they are manufactured by the process either which is used in case of manufacturing of bricks, or we may adopt certain variations of the same. But depending upon the process that we've taken up, the shape that we are going for, the color that we are imparting or pattern that we are adopting for our tile, the tile will be given its specific name. Now there are various types of tiles which are available, but we can predominantly try to classify them as plain or flat tile, curved or pan tiles, pot tiles. We can also call the pot tiles half round country tiles or Spanish tiles. We also have the Italian or Allahabad tiles or the interlocking tiles. So first let's take a look at the plain or the flat tile. Now plain tiles are made up of clay or concrete, and as the name suggests, it's plain as in it is made in rectangular shapes of varying sizes. So it can be from 25 cross 15 to 28 cross 18, and the thickness can also vary between 9 mm to 15 mm. Now the tiles are not perfectly flat as per se, but they have a slight camber of 5 to 10 mm in their length to ensure that the tails will bend and not ride on the backs of the ones in the lower course. So that is, if we are placing the tiles at one after the other, we want to give it a certain upward tilt so that it doesn't ride on top or kind of rest on top of the lower course. There is a certain gap that is maintained. So for that, we do not make it perfectly poker straight, we just give it a slight camber to it. Now common rafters are laid at 20 centimeter to 30 centimeter spacing before we are laying the tiles on top of it. So the common rafters and the tiles are not in contact. What we are doing is we are making the common rafters. On top of that, we are adding the battens, or we can also use boarding, and they are fixed across the rafters at a spacing of 4 to 6 centimeters. On top of this, the tiles are then laid over this with sufficient overlap on the sides and edges. So that means when we are looking at it horizontally, there is a certain overlap between each course. As we are moving from the ridge towards the eave, there is going to be a certain overlap in the tile. Now why we are doing this is because we do not want rainwater to enter into the internal spaces, so certain amount of overlap is required in both the directions. Now for gentle slopes, every 4th or 5th course is nailed, but if we are having a steeper slope, we might necessarily have to nail every single tile. Otherwise there may be the problem of the tiles slipping off or coming off from the roof if the pitch is higher. Now pan tiles, another type of tile, are 33 to 36 centimeter long and 22.5 to 25 centimeter wide and about 12 to 19 mm in thickness. Now these are flat longitudinally but are curved transversely. They are slightly S-shaped curve or a flat wave is provided in this type of tile. Now the pan tiles are laid with overlapping side joints, and the side lap in pine tiles varies about 38 mm to 50 mm. The head or the longitudinal lap varies, it's slightly more between 7.5 to 10 centimeter. And this will of course depend upon the pitch that we have adopted for our roof. So as you can see here, there is a slight curve to the particular type of tile, but of course longitudinally if we see, it's flat. The half round country tiles, they are also known as the pot round or Spanish tiles, and these tiles are usually semicircular in section at each end. Now, but the diameter tapers longitudinally. So though there is a slight curve throughout the tile, it will be slightly narrower in one end and wider on the other. Now these tiles are laid in pairs of under tiles and over tiles. So we will always have two shapes coming together. Now the under tiles are laid with concave surface upwards, while the over tiles are laid with convex surface upwards, as one can see in the figure depicted here. The next type of tile is the Allahabad tile, which also comes in pairs, but in this case the flat broad bottom under tile, which is alternated with a convex curved over tile. So in the previous example we had curved tiles both in over and under tile, but here what we are doing is we have a curved above tile and the under tile is actually flat. Now the under tile is flat tapered with upturned edges, that is upturned edges, it will be slightly turned upwards at the ends, and it measures 23 centimeter at the interior end or the tail end and 26 centimeter at the head end, with a length of 37 centimeter and flange height of 4 centimeter. Now this is of course a broad specification. It's possible that locally the size may vary. It doesn't necessarily have to be exactly the same, a permutation and combination of this. The over tile is half round in section and tapered in plan. The diameter tapers from 16 centimeter at the tail to 12 centimeter at the head. So that means just like the previous type, here also the curved over tile is going to have a certain taper to its longitudinal shape. The head lap varies from 6.5 to 7.5 centimeters depending upon the slope and the side lap. Now the taper is over tile allows the tile in the next course to fit into this overall framework. Now the framework consists of rafters to which 5 centimeter to 2.5 centimeters battens are fixed, and the vertical battens are fixed between sides of adjacent under tiles, and to these the over tiles are fixed with the help of nails. The interlocking tiles are available under different patent names with specific locking mechanism to prevent their dislodgement even under extreme weather conditions. So this may vary from place to place, but what would be common between all these types is that these tiles are generally machine made and they have a very specific frog created. You must have come across the term frog when you were dealing with masonry. So there is a certain joint which is created because they fit together in a certain pattern. Now this change in pattern is what is going to give it its name, and it will vary between company to company throughout the nation. Now let's move on to the sheets. The first type of sheets that we can opt for is the asbestos cement sheets, and these are cheap, lightweight, tough, durable, definitely water resistant, fire resistant and vermin resistant. Now asbestos cement sheet is most popularly used for industrial buildings, factories, sheds. We can also opt for auditoriums and cinema halls, and in some cases residential buildings as well. Now they are available in bigger units unlike tiles, and thus the supporting framework is also cheaper, easier and lighter, because now we do not have to have very closely spaced members to support this roofing material. The number of battens that we have to use to connect between the roof covering and the common rafters is significantly reduced because the sheets come in much larger sizes. The tiles, because they are much smaller in size, will have to be nailed very regularly. As a result, there would have to be much larger number of battens. Now as we increase the number of members, the overall weight of the structure increases and subsequently the price also goes up. Now these sheets do not require any protective paint and no excessive maintenance is required. Now the construction process with AC sheets is quite quick and easy. The AC sheets are manufactured from asbestos fiber, approximately 15%, and Portland cement. Asbestos is found in several varieties, but white asbestos, which is a compound of magnesia and silica, is predominantly used. And in India, we can opt for 3 different forms of AC sheets. We can go for the big 6 corrugated AC sheet, the standard corrugated AC sheet and the Trafford AC tiles or sheets. Now these sheets usually have a length of 1.25 to 3 meters. So the first type, which is the big 6 corrugated AC sheets, they have 7.5 corrugations per sheet. Their overall depth is 55 mm, and these sheets are fixed directly on either steel purlins or wooden purlins. So the whole need for battens is removed in this case. Of course, we will be introducing a certain amount of side overlap between adjacent sheets. The standard corrugated AC sheet is similar to the big 6 one. Here the overall depth is 25 mm. These sheets are fixed directly with smooth surface uppermost to either steel purlins or wooden purlins, and they, unlike the previous big 6 example, have 10.5 corrugations per sheet. Now the head or end lap is 150 mm and the side lap is equal to approximately 1.5 corrugation as depicted here. So this 1.5 corrugation can be up to 100 mm approximately. The Trafford AC sheets slightly differently shaped as to the previous examples. They are large tiles of 1.09 meter standard width. Each sheet has 4 50 mm deep corrugations alternating with flat portions. So 4 of these equally spaced out. Now they are fixed to steel purlins by 8 mm diameter bolts or straight bolts, and to wood purlins by about 115 mm long driving screws. Now the head lap is 150 mm again, and the side lap is approximately 1 corrugation or 7.4 mm, as opposed to in the previous example we were going for 1.5 corrugations or approximately 100 mm gap. In case of the Trafford AC sheet, we will reduce the overlap on the side because the interlocking mechanism in this type of sheet is better. The basic procedure for laying these AC sheets is that they are laid either from left to right or from right to left and at an opposite direction of prevailing wind and rain. Now the purlin are spaced adequately to provide specified overlap at the intermediate point and specified overhang at the eaves. So at the end where the slope comes and ends, there has to be sufficient overhang. Otherwise, of course, the underlying wall is going to be hit with side rain. Now the sheets are fixed to the purlins using screws or bolts, and the holes are made 3 mm greater than the diameter of the bolt, and coach screws are generally used when we are dealing with wooden purlins as opposed to steel purlins, and crank bolts are used in case of steel purlins. Specific spacing of the purlins are required. Maximum 1.6 can be provided, and as we gradually move towards the eaves, there has to be a certain overhang. The laying always starts from the eaves. The eaves course is laid first. So we are starting from the bottom of this pitch, and when the laying is done from left to right, the first sheet is laid uncut, while the subsequent sheets in the bottom row should have their top left hand corners cut or mitred. If the sheets in the second row or intermediate rows should have both the left hand top corner and the right hand bottom corner mitred, except the first sheet, which should be only in case of the top left corner mitred. The following points should be considered while we are laying the AC sheets. The AC sheet should be laid with smooth side upward and the end marked top pointing towards the ridge. So whichever is the marked point of top should be towards the upper side. The end laying and the side lap should be properly maintained. Generally end lap is about 15 centimeters, but it can vary from based on the purlin spacing. The holes for fixing accessories should be drilled and not punched in the crown of the corrugations. Under the GI flat washer, bitumen washers should be provided. The nuts of the screw or bolt are moderately tightened when 10 to 12 sheets have been laid. They should not be screwed very tight. The ridge cappings should be secured to the ridge purlin. This is the ridge capping on top, which is the curved member surmounting this ridge portion. That should be secured to the ridge purlin, and the sheet should be mitred properly as required. The unsupported overhang of AC sheet should not exceed 30 centimeter. The next type of corrugated sheet we can use is the galvanized iron one. Now GI sheets are made up of iron that is galvanized with zinc to protect them from rusting action of water and wet weather. Now GI sheets are made with corrugations running from one end to the other. The corrugations impart additional strength to the sheets. Now they are stronger than AC sheets, but is comparatively costlier, and they are not used for slopes flatter than 1 in 4. These sheets are fixed in a manner very similar to the previous example, which was the AC sheets. The next type of roofing one can opt for is the slate roofing. Now slate is a hard, fine grained sedimentary or clay stone. The thickness of the slate slabs may vary from 4 to 8 mm, and the slab sizes can vary from 600 mm cross 300 mm to 400 mm cross 200 mm. Now slates are laid so that each slate overlap a slate in the next course, and the size of the lap between the two courses depends of course on the pitch and the amount of exposure that this roof receives. Now slates are fixed to the battens by means of copper or zinc nails. The next type of roofing is roofing covering that we can use is the lightweight roofing. Here we have a few options. Now, to ensure an economically feasible structural framing for wide span industrial structures, it is desired to reduce the weight of the roof covers. So, that is when we opt for the lightweight roofing material. There are two types. We can go for sheeting. Now, sheeting can further be classified into two parts. We can have aluminium sheets or asbestos cement sheets. Other than sheeting, we can also go for decking. Here our options are wood wool, straw board, aluminium alloy and steel decking. Now, sheeting is used for sloping roofs, while decking is used both for sloping as well as flat roofs. So, depending upon the context, the situation, we can opt for any of these selections. Let us take a look at each of them one at a time. Aluminium sheets are those which in which the aluminium roof sheeting consists of alloyed aluminium with a small percentage of manganese for strength. It is the lightest of all the roofing materials. Definitely aluminium, as we know, is quite lightweight, gives it a huge advantage, reduces the sections of the supporting members in the overall roofing framework. The wood wool decking is made from wood fiber, which is interwoven together and cement bonded under pressure in a mold. Now, they are available in the form of slabs, which varies in thickness from 12 mm to 100 mm and is 0.6 meters in width and up to 3.5 meters in length. They have good sound absorbing and thermal insulation properties. The slabs used for roofing are generally 50 to 75 mm in thickness, and when unreinforced can take up to a load of 0.75 kilonewton per meter square. Now, they are nailed to timber joists at 600 to 900 mm centers using 102 to 125 mm long clout nails. In case of the straw board decking, it is made up of compressed straw with thick waterproof paper covering. The thickness is 50 mm, width 1.2 meters and length can vary from 1.8 to 3.6 meters. Now, for roof decking, the board is supported to 600 mm centers all along all the edges. Now, the aluminium alloy and steel decking, in this case, the aluminium alloy and steel are pressed to form a troughed roof deck. The thickness may vary from 0.7 to 1.2 mm. The depth can vary from 25 to 85 mm. Widths between 450 to 900 and length a maximum up to 10 meters. Now, they are suitable up to a superimposed load of 0.75 kilonewton per meter square. The top surface is finished with a layer of white stone chippings which are spread on bitumen to provide solar reflectability and reduce the heat absorption in summer. So, those were the different types of roof coverings that we can use in our structure. Before we end today's lecture, let's again take a quick recap. So, we started off discussing the different types of pitch roofs. We've covered this in detail in the previous lecture. I hope you've gone through the same. So, we have single roofs, double or purlin roofs and triple member truss roofs. In single roof, we can have lean-to roof, couple close roof and collar beam roof. In case of trusses, we can have king post or queen post trusses, a combination of the same, a mansard, truncated or latticed roof trusses. With respect to materials, we can have composite roof trusses and steel sloping roof trusses. Now, we further went into the detail of steel sloping roof trusses in this lecture. So, we can have various types of shapes which are useful for different spans. For example, the king post truss can be used for 4 to 6 meters. We have the scissors truss, the raised cord truss or the which can go up to 9 meters. We can have the hoe truss, simple fin truss and the fan fin truss. We have also options of using north light trusses, modified north light trusses, sawtooth option. We can also have the bowstring truss which is curved. This can go up to a span of 20 to 30 meters. We have compound fink or compound hoe trusses which can go up to 12 to 15 meters in span, and also we can have a compound hoe truss with raised cord or a compound fan fink truss. These also can go up to 15 meters. We can also go for the cambered fink or French truss. So different shapes of steel trusses are possible for different types of spans. Then we went on to study the different types of roof coverings that we can use. The thatch covering, which was the cheapest, but of course it requires significant maintenance, its durability is low, and also it is highly inflammable. But of course it is lightweight and it can be applied to smaller spans very easily as long as the weather conditions are not very harsh. Wooden shingles are roof coverings which are made up with timber itself, so we can opt for this if timber is locally available and cheaper for us. Tiles, of course, a very popular option, but there were many categories of tiles depending upon the shape. So the mechanism of overlap, the ways the lapping happens, the shape of the tile, the pattern, etc. will vary from local areas, and based on that we will use different terms to describe our tiles. Asbestos cement sheets and galvanized iron corrugated sheets are another very popular option. We can also use slates and different types of lightweight roofing materials, of course within which aluminium finds a lot of applicability in the lightweight roofing structures. They have the possibility to reduce the overall weight on the structure significantly and have restrictions with respect to the amount of load that they can take. Now, while finishing these types of sheet roofings, we can use stone chippings along with bitumen, etc. to ensure that the solar reflectivity is maintained, and we can reduce the amount of heat that the structure is being exposed to. So these were the different types of roof coverings that we can apply to our pitch roofs, which brings us to end to this module of roof. With respect to flat roof and the type of terracing that can be applied on flat roofs, we are going to be covering that in subsequent modules dealing with damp proofing. These are some of the references for further study. Thank you so much for tuning in. See you soon in the next module. We are learning the basics of building construction. I hope you come back to learn a bit more about the next module as we are gradually moving from the lower part of the building, that is the foundation, to the walls, to the roof, and the other components that bring together and help us create the construction process of building a house or any other building. So thank you for tuning in. See you soon.